All right. And so with that, go ahead and go over to the next slide. So as mentioned, I work for a big well-known organization as an InfoSec engineer performing DFIR on a CCERT. I also run the SIMPA Security SIG, which is a local information security meetup organization based out of Cincinnati, Ohio. We meet third Thursday of every month. Our meetings are free to attend, and amid pandemic concerns, we've moved to online only. So I'll try to share out a link in the chat if people want to stick around and see what we have in store for next month. So just a quick disclaimer that yes, I do have a day job, but the opinions expressed are based solely on my own independent security research and do not express or reflect the views or opinions of my employers, past nor present. So my objectives for this talk are to learn and understand how APIs are abused by malicious threat actors, the risks associated with poorly coded APIs, and see the technical details of how exploited web API vulnerabilities may lead to a data breach. We've all seen how that plays out in the news, right? So I'm just going to start at the very beginning here of what is an API, and my own personal keep it simple stupid definition is an API is an application programming interface. APIs allow access or interaction between systems. They often provide developers and power users with a means to access or leverage data and services on external or cloud-based systems and services. APIs may grant read, write, or modify permissions depending on design, configuration, implementation, and applied permissions. Why is this important? Web APIs increase attack surfaces with the possibility of a potential avenue for compromise, data exfiltration, destruction, or manipulation in an otherwise reasonably secured system. Web APIs are purposely targeted by cyber criminals in the event that finding an exploitable vulnerability may lead to a system compromise and or data breach. I want to talk a little bit about what REST is. So REST is an acronym for Representational State Transfer. Web services that conform to the REST architectural style called RESTful Web Services provide interoperability between computer systems on the internet. So I want to talk about the Tiredful API, and I'm guessing that it's developer humor that we go from RESTful to Tiredful. But the Tiredful API is an intentionally broken web app by design. The purposes of the application is to teach developers, QA testers, or security professionals about flaws present in web services, the REST API due to insecure coding practices. And if you do get the slide deck, this is a hyperlink to the Tiredful API. They'll take you out to the Git repository for that. So some of the Tiredful API vulnerabilities include information disclosure, indirect object reference, which is commonly called IDOR, access control, throttling, SQL injection, or SQLite as you see it often, cross-site scripting, XSS. And just some quick housekeeping. For demo purposes, I'm using the Firefox web browser with the REST client extension. Some challenges require authorization under an account with appropriate access. Exercises involving access to protect data require an access key. And I'm not going to go into OAuth a whole lot, but just real quick high level, the token credentials consist of an access token and token secret used in lieu of a username and password. And the required token type, it typically uses the string bearer under most implementations. It would be very rare to see anything else. So essentially you have an access key and it's going to be presented as the bearer of that key that gets passed along to OAuth. Potential access token exposure. This is not an all-inclusive list, but some of the ways that access tokens are stolen or exposed include things like intercepting proxies, man-in-the-middle, probably kind of rare HTTP 307 attacks where it's fooled into sending that. Probably pretty rare, but it wouldn't surprise me if it's happened somewhere before. Open browser sessions or browser history, particularly when it's included as part of the the web address, cross-site request forgery attacks, tokens stored in JavaScript in code, tokens stored in unencrypted session cookie, and probably a number of others. So that's typically how these things get exposed and how some of these attacks are possible. So getting started with the Tiredful API running, you just open up, in this case, the loopback address, port 8000, and we'll click on user token. And I've already done that, but I'll show it real quick. And then we log in to obtain a user token. There's a couple accounts included. One is Batman. And then note the returned access token value. And then I'll show that real quick, and then we'll get into the first demo, which is about information disclosure. So sensitive data type examples would include like financial data, PCI, account data, credit cards, personally identifiable information, system stack trace information, which can be useful in reconnaissance. And if you're familiar with the OWASP top 10, these are A3 in the 2017 edition for sensitive data exposure. And with that, we'll go ahead and take a look at that, and we'll go ahead and go through the first demo here on information disclosure. And as you'll see in the Tiredful API, the objective is to try to get stack trace information. So let me see if I can bounce over to Firefox here. I've already gone ahead and logged in using the username and password, which they provide up here. And that's given me access to an access token down here, just simply by clicking the Get Token button. It gives me that information. I'm going to go ahead and bounce over to the Tiredful API, and here's the challenge on the information disclosure. Library decided to provide services to other third-party through its APIs. One of the implemented API is to get details of the book by providing the ISBN number. We suspect the API is revealing interesting information apart from book details. And then here they give us the method, which is going to be HTTP GET method, and the site address, and then a list of different ISBNs that we can test this with. And so for that, I'm going to go ahead and bounce over to the REST client, as I mentioned in the slide deck, as to what I'm going to be using. Now, I did copy these commands out just so I can copy and paste and get through these demos a little faster, so we're not here all night. Go ahead and throw that in here, and let me make sure my headers are what they need to be. It looks like I need the get method. I need an accept header. So we'll add the accept header. So we're going to accept essentially JSON. This doesn't require a need for a body. And so just to kind of break down the REST client here, this is the method we're using, like get, post, and put, delete, options, head, trace, connect, patch. Essentially what we're using the test with. URL should be pretty self-explanatory. That's the web address. Headers are sort of important when we're communicating with the server. And then what we'll get down here is the response, and then like the headers, the response, and the preview. And what we want to look for here always, this is important whether you're talking offensive security or defensive security, but the server code, the server response code that you get back, or the server reply code that you get back will tell us a lot about what happened. The neat thing about this utility, when you run it, it actually gives you the curl command, which you could then run from the command line to essentially do all these things without the need of a external client aside from curl. So hopefully that's just a quick nickel tour. If I go ahead and send this, it'll hopefully make a little more sense if it didn't already. But I've sent that. You can see in the headers, here's the server status code. And if you look up HTTP status codes, you'll get some good results. So 200 is okay. 200 means the server essentially accepted the request. The results may or may not be what we expect, but at least the request was something that the server recognized. And here I talked about the curl command that you could run independent of a web extension to essentially get these same results. So let's see what we actually got back. So we sent that, and again, we had in our address that ISBN number right here, and they give us a few examples. And aside from the response, if we look at preview, again, we get a JSON, nice JSON formatted breakdown of that. And pretty much everything looks here as we expect. And again, the purpose of this is information disclosure, and they challenged us with getting stack trace information, which all I'm going to do here is just simply change the web address and change the number 2 at the end to like the capital A and see what we get. Notice we still have an HTTP 200 status code, so the server accepts the request. Let's see what the response is, though. This gets really interesting really fast. I'm going to click on preview here. But now all of a sudden, instead of getting an ISBN results, we start getting some interesting information. So we start seeing, the directory structure of where this thing is actually running from, which could be useful for things like traversal. And if we keep looking a little more, we start getting specific line details. This gets really interesting. So if this is a production server, we can actually tell based on the path that it's running Python 2.7, which really went into service, into life at the beginning of the year. So chances are, we could do research on that to find out what Python 2.7 vulnerabilities have come out since January. And there's a good likelihood that this might be vulnerable to that. We also know some other things. So we know in the path that it's running Django, the database, and we start getting, again, some more of the particular files, which could be helpful if we're trying to leverage things or if we wanted to research potential attacks there. So this is information disclosure. This is the kind of stuff that you wouldn't want getting out, and really a way to define that kind of information. So that's the first exercise. Let's go ahead and kind of reset here and go on to the next part of the slide. With that demo done, the next thing we want to talk about is insecure direct object reference, IDOR risks. Some of the risks are the failure to restrict access appropriately. So this might allow threat actors to exploit flaws to gain unauthorized access to data or traversing other parts of a system. And I think in the olden days, this may have been OWASP, like in the, the prior version, 2013, I believe. This may have been like A3 on the list. They kind of combined a couple things and simply calling it broken access control. Still in the OWASP top 10, though, it's A5 for IDOR risks. And in this case, our scenario is insecure direct object reference. And the objective they want us to do is to try to access exam results of another user. So let's go ahead and bounce back to the Tiredful API here. We're going to go ahead and look at this next exercise. And here we have the challenge for IDOR. An online exam portal provides an API to access the results of attempt exams by a student. And what they instruct us to do is log in with Batman and try to access exam results of another user. And then they give us, following our exam ID of test attempted by Batman, they give us 2 examples. And here we can see we're using a get method, which means we're just doing a simple retrieve. And then we're going to grab the exam IDs that we should have access to. But again, our objective is to find things that we maybe shouldn't have access to. But for this purpose, if you remember, they did tell us to log in as Batman. So that means that we're going to need that access token. So if I come back here, I'm going to go ahead and add this or grab this and then go into headers, and I need to add a custom header, and we'll do authorization. And remember, we talked before in the slide deck about bearer, and we'll just do equals and paste this in here. And the sample exam IDs they gave us were, one was a capital MQ equals. So we'll go ahead and do that and see what we get here. So we send that. again, this is important. Our HTTP status code is 200 from the server. We look at the response, and so this is a physics test, and it's for user number 1, which we know is our Batman person. And if we preview it, we just get a nice little easier to read JSON formatted response. And it gives us some of the test score information. So good stuff. The other one they gave us was capital M, lowercase g equals equals. And we run that. And again, status code looks good. We go to the response, and this time it's a chemistry exam rather than a physics exam, but we're still user 1. Again, this is stuff that logged in as Batman we should have access to, so this is okay. One of the things that is interesting is when you start seeing equal signs at the ends of strings, that's usually a pretty good indicator that it's base 64. So let's go ahead and prove that out. So if I do echo, let me make this bigger, so it's not so small to read. Hopefully that's a lot better. So I'll do echo and then MQ equals equals, which is what we had. And let's go ahead and pipe this out to base 64. And -D will decode that for us. And then I'm also going to just throw in some white space at the end. So echo, and then a couple double quotes here. And so we have number 1. If you recall, the second thing we had was MG equals equals. Notice this is number 2. So we're going in sequential order. And if it looks good this way, then the inverse should also hold true. So if I do an echo -N to put it on a new line, the number 1, and basically pipe that out to base 64, sure enough, the inverse is true, and number 2 should give us, right, the M, capital M, lowercase g equals equals, and sure enough, it does. So let's, and again, the goal here is to try to get something that we shouldn't have access to. So let's try a number like 56, and we get the results we get are capital NTY. Let's go back to this, and we'll just simply change this N part here, capital NTY, 1 equals, and again, we shouldn't be able to see stuff that's not ours. We send that, server liked it, we got a 200 status code. So we have a physics exam. Notice this time it's user 2. This is something that we should not have access to. And just to prove we didn't get lucky, if we come back here and let's do something like 93, and then we get a capital OTM, we'll just repeat real quick just to see if this works for us. And we'll go ahead and, oops, yeah, I do have the cursor in there. OTM equals, send that. We come back in again, our HTTP status code. These get to be really important. As I've been talking about, we look at the response we get. Again, now it's a speed test, but more importantly, it's for user 3. Again, this is stuff we shouldn't have access to. We shouldn't be able to see any other user other than our own. So that's part of the problem with insecure direct object reference, is it's allowing us to get to things that we really shouldn't be able to get to. Go ahead and clear this up, and we'll go back to the slides here. The next thing we're going to talk about is access control. So the risks around access control are allowing unintended access from the way a system or application was designed, which would include failure to restrict protected or administrative actions to authorized users. And this also maps out to OWASP top 10 list. This is A5 from the 2017 version, which is broken access control. So these kind of things are a big potential problem. And so in our third demo for access control, we're going to try to execute an operation which only be allowed to admin users. So let's go bounce back to the Tiredful API, and we'll look at this exercise there. So I'm going to click on access control, and the idea behind this is a blog application allows users to create, edit, or view articles. Developer decided to implement web services. So for testing purposes, developers provide access to 2 API endpoints. And so to view an article, you would run this get command with an article ID, which you can see the ID numbers down here. And then article approving, which should be an admin only function. You know, it's just a little bit different when you look at the addresses. Instead of just pulling up the article, it's doing an approve article with an article ID. So those are the kind of things that should be required from us. We'll go ahead and see though. So I'm going to come back here. And for this, I just need the accept header, which is what I have. And then, yeah, we're just going to do a get request. And let me go ahead and get that article ID. Number 2, I believe, is first in our list. So I'm just going to copy that real quick. Come in here and paste it in here. And we'll see what we get. I'm going to send this. And again, our status code, very important. I pretty much check that thing every time to see what kind of response I'm getting from the server. And we look here, and you know, the results are kind of what we expect. Here's the curl command to get it. We've kind of talked about how that works. Here's the JSON format for the second article. So our goal here is to try to do something that would normally require admin rights, because at this point we're just retrieving it. So if we come back here and look at headers a little bit closer, notice what's allowed. The first thing in the list is delete. If somebody's just supposed to be able to view something, they really should not have delete permissions to it. The options get in patch are a little bit less concerning. So the question is, can we just delete this simply by changing our method to delete? Well, let's try it and see what happens. So do that. Again, the server's okay with the response or the request because they give us a 200 response code, but is the response really what we expect? And the response we actually get back in this case, and even if we preview it, is admin header missing. So it clearly didn't work maybe like we expected. So let's see if we can add a custom header to do that. So we'll go ahead and call this isAdmin, and we'll give it a value of true. And that's the only thing we've changed. Let's go ahead and submit the same exact request, just with that in the header now. And again, we get a 200 code. We've been getting that. This time though, we look at the response and it says it was successfully deleted. And if we preview it, it's going to give us the same thing. Question is, did it really delete it? Let's go ahead and just repeat the search how we were doing it just a moment ago, and it worked perfectly fine. And the only thing I changed is the method back to get. I send that, and oops, yeah, if I look at the headers, you know, here's a telltale sign, 404 not found. Remember, just a moment ago we were getting 200. It was an acceptable request, and you know, the response, it's just gone. It's not there anymore. And again, we are not using an authorization token. We haven't used an authorization token for this whole example. So yet we have the ability to just delete whatever we would want out of these original article IDs. I'm going to go ahead and set the table real quick for throttling. Bear with me here, and then we'll go back to the slides real quick and talk about that. So the risks around throttling are denial of service is a big one, a way to flood the system resources, which effectively makes a system unavailable. And that, of course, prevents legitimate users from access to a system. And then the actual exercise here, throttling, aka rate limit implementation, the objective in the exercise is to force the server to respond with HTTP response code 429 to abuse system resources by launching a denial of service attack. And just a quick note here, HTTP 429 response code means too many requests. So that's our classic denial of service example. This matches up with A5 from the OWASP top 10, which is part of broken access control again. So let's go ahead and go back to it and see how this works. And again, if we go back here, the challenges show the missing rate limit implementation issue. Missing rate limit implementation allows attackers to abuse system resources by launching a denial of service attack. So here we've got basically, we want to use a post method to this, address, and then here's the body that we would include, and then the PNR number is part of that. So let's go back to our REST API client, and again, our aim is to force the server to respond with HTTP response code 429. I'm going to go ahead and throw this in here. Go ahead and grab the body that we want here. Here's that PNR number. And before I launch this, I do want to show something that I wrote. Well, actually, let me go ahead and change my method to post. And for our headers, I've got the accept. I also need to add content type to this. Let me do that real quick. So, all right, that looks good. Now, if I send this, it should hopefully look normal right now. So I'm still getting a 200 response as far as the, reply code from the server, our status code HTTP 200. So that's good. We look at the response. It's giving us, the number, this PNR number and details about the train number and so forth. So it's working as it should. And before I launch, I actually wrote a real small bash script. And what this does is this bash script essentially just runs a for loop, and it starts at the number 0. It goes 10 times, incrementing by 1 each time. And each time it's running the curl command, which is pretty much identical to what we have back here in the Tiredful API when we look at the curl command. This is pretty much what we have. And this is something that a threat actor would probably not do, but I did put a sleep of a quarter second just so people can kind of see it a little bit. And then it just stops after it's run essentially 11 times because it starts at 0 and goes to 10. So let's go ahead and see what the script does in this case. Let me go ahead and clear this, and I'm going to go ahead and run the script. And you can see we're still getting HTTP 200 requests. It finished, so it ran the 11 times, bounced back here, resend, and again, HTTP 200 code still looks good. If I bounce back here and rerun this shell bash script again, now we start seeing 429 errors in the response. Let's go back to the REST client, send it, and see if that's showing it the same thing there. And sure enough, it is. So here's our 429 HTTP code from the server. We look at the response in detail. Request was throttled. Expect available in 3,483 seconds. Same thing when we look at the preview. So that's effectively knocked this thing offline. And just from a defensive standpoint, obviously this is something you would want to start doing rate limiting within the code, ideally. There's maybe a couple other things you can do. If you have like a WAF, for example, a web application firewall, you might be able to look for too many requests coming from something and basically block those. At the server or host level, I don't know if in the Pwn School meetings they've covered fail to ban. Fail to ban is something you can run on a server that essentially looks for excessive traffic coming from whatever IP address, really at the host level. And it does what we call tar pitting. So it will essentially find a malicious IP address and it'll block it for whatever you want to set it to, 5 minutes, an hour, 24 hours, a month, an entire year. A couple things that can be done to mitigate that, but those compensating controls, I would still recommend fixing it back in code on the server end. It's really where it ought to be, simply because people are constantly researching WAF bypasses. So you don't want to depend on those if you don't have to, is I think the moral of the story there. The next thing we're going to look at is SQL injection. Let me go back to the slide deck here and just kind of clean up after myself first. And so we'll go ahead and talk about SQL injection. SQLi risks, obviously, are vulnerabilities which allow unauthorized access to a backend database. And the abuses can include things like data exfiltration, data destruction, or data manipulation. And again, this is also in the OWASP top 10 list, right? It's A1. It's like at the very top of the list. It's been at the very top of the list probably since its inception, or very close to it. Maybe the whole time. It's been a problem for a very long time, and yet it still just doesn't seem to go away. So our demo, we're going to look at SQL injection, and the objective, as you'll see in Tiredful API, is to find table names of the SQLite database. So let's go ahead and bounce back over there and see if we can do that. So for this, I am going to need accept and content type headers, I believe. So that does look good to me. And let's go back to Tiredful API. So yeah, API is implemented to serve a fitness tracker mobile app. It's used to check fitness activity in a month. Following is the API endpoint to access monthly fitness activity. And they give us the post command, the body of that, and then they give us some examples of the data we should find. And the aim here is to find the table names of the database. And it is SQLite. So if you're used to looking at MySQL, for example, the syntax is just a little bit different, but we'll go ahead and go through that. And it's not such a radical departure that, you know, when you see it, it won't make any sense. So what we'll do first is just do a basic query and see what that looks like. So I also need to, we need post method. I've got the address. Let me go back and get the body that we need to, submit for that. I don't need that anymore. All right, here we go. So I'm going to paste this in here. And so what this should do is this should give us a result. We'll submit the request. Looks good so far. We got an HTTP 200 status code from the server. We look at the response, and sure enough, this looks like a good result. If we click on preview, we get that nice JSON background. And if you remember, the objective was to get the table names, and we want to try to do that by using a union select. And how we're going to try to do that is we're not going to actually count the fields here. So sleep is one of our fields, heartbeat is one of our fields, calories, running, month, user. So we got 1, 2, 3, 4, 5, 6. So let me go back to here, and I'm going to go ahead and copy out our command body, well, the body from that, and replace our month equals 1, or really kind of append to it. So it kind of looks like it did before, only we're also throwing in a union select. Here's our 6 field values. We're going to do it from the SQLite master database, and where type equals table, to try to get the table names from this. And we go ahead and hit send on this. Again, 200 code from the server, so that looks good. We click on response, and pretty cool. So we get a big dump of information here by running SQL injection against this. And I'm guessing that these are our table names at the end. But fortunately, since this is on a local system, we can prove it. One thing I like to use, and I kind of can't talk about this thing enough, is the DB browser for SQLite databases. This should be in pretty much anybody's toolkit. It's reasonably light on resources, It's also cross-platform, and I know at least runs in Linux and Windows both. This is good for a lot of things, pretty much anything using a SQLite database. So it's free, so definitely no reason not to use something like this. So let me go ahead and shrink it down a little bit though, and we'll just kind of stare and compare and see, what that looks like in terms of here we have the list of tables, and we have what we think are the list of tables over here. So we have advertisements classified, auth group permissions, permissions. These things essentially are matching all the way down to trains reservation at the end. And we know from here we have the 21 tables. We could count them up and know that we've actually definitely gone ahead and retrieved those tables as the example suggested. So good stuff. And then that's going to take us really into our last exercise here. Let me go ahead and clean this stuff up. And the last one is probably going to be a get method. Let me switch that up. And let's go back to the Tiredful API real quick. And it's going to be in cross-site scripting. We'll go back to our slide deck to talk about this. So cross-site scripting, some of the risks involved with XSS include, performs automatic code execution in client browsers upon access. So this is a way that threat actors can use to essentially run whatever code they want whenever somebody just simply visits a site that has this vulnerability. So this is a very bad vulnerability. XSS has also been around for a very long time. And it can lead to stolen credentials or form data, execution of exploit kit payloads. Just a lot of different bad things can happen when you have XSS vulnerabilities. And again, it's been on OWASP top 10 for pretty much forever. It's actually dropped down a little bit to A7, but it's still on the OWASP top 10 for sure. And then we'll go ahead and go through this last demo for the night on this, which is our cross-site scripting XSS demo. And the objective for this will be to find parameters accepting cross-site scripting meta characters. So let's go ahead and bounce back to the exercise here. So the challenge for cross-site scripting in Tiredful API is an advertisement portal where a user can post and see classified advertisements. APIs are implemented for accessing the list of classified advertisements and to create the advertisements following our API endpoints. So to list them, we would simply run the get command to post to them. We would follow, just a little bit different format here. Or different method rather. So we have the site address. We'll go ahead and copy that out and go ahead and throw that into the REST client. And down here, we've got essentially the body that we would want to include in that post. And again, the aim here is to find parameters accepting cross-site scripting and meta characters. So let's go back to Tiredful API and take a look at this. So headers I need are accept, content, that looks good. And I think I also need that authorization token. Let me go back one more time and grab that. So authorization, and again, just like before, bearer equals, and paste in that access token, okay it. Now that's included in the headers. Let me go back to my quick copy here. Bounce back to this, throw that in the body. Make sure we're starting on headers. All right, so what this should do, and the method definitely needs to be post because we're sending data to the server to post on that for this part. And this is the data that we're sending to it that really just sort of matches the format they give here, right? Headline, info, price. So we're just providing values. Go ahead and send it. And notice we get a status code of 201 created. So again, that's why these status codes are really important because it really tells you on the back end how the server is seeing the requests. And if we look at the response, then it looks like it, definitely did include what we wanted it, previewed to get the nice JSON formatting. So that accepted it. That's kind of working exactly how it was intended to work. But again, our goal is to try to get to work like it wasn't intended to work. So we're going to go ahead and throw some cross-site, oops, sorry about that. Didn't want that one up. We're going to go ahead and throw some cross-site scripting in here. And so instead of providing the real values for things like the headline, the info, we're going to go ahead and put in a script alert. And if we're, on the API side, if we're not using, if we're not sanitizing inputs, doing input validation, those kind of things, this could be a problem. If we, if we are doing those things, it should block this from happening, or certainly strip it out. We'll go ahead and send it and see what we get. Again, it tells us it created it, but let's see what the actual response looked like. And so sure enough, we start seeing the JavaScript where it would pop up an alert box saying pwned, for a couple of those fields. We look at the preview, and again, it's exactly what we just saw. And then if we come back here and clean this out, remember there was the get, and it was really the same address. It should list out everything that's in here. And again, 200 status code. We're not seeing the 201s for created since we're getting it. We're just retrieving it. But sure enough, when we retrieve the results, we see this information here. This was the first thing we put in, and then here's the second, and it did not strip out the JavaScript alert box pop-up. But again, this script could be anything we wanted it to be. As a malicious threat actor, they would start doing other things to, essentially do bad things back on the real web server when that would be brought up. So we'll go ahead and go back to the slide deck and wrap it up here. But did want to talk real quick about just some real high level stuff on reducing these kind of risks, particularly for developers. The recommendations I would have would be, adopting a secure development lifecycle, and then trying to get a security champion in every dev team. That's like my move the needle in the right direction pipe dream maybe, but that's one I hang on to nonetheless. And I've actually tried to take my message about doing information security to developers when and where I can. It doesn't do us a whole lot of good if we all stay in our own silos and we don't extend that olive branch out to developers. If you're only going to a developer to tell them, hey, man, I totally exploited your code and pop stuff and whatever, that's not endearing yourself to them if that's the only time you ever come to them. So if they can sort of catch this low-hanging fruit by testing some of these things out themselves, it just really makes it better for everybody. Then QA doesn't have to kick it back to them. They have to work on it. It has to go through revalidation, all that stuff. So the quicker you can put this stuff into the software development lifecycle, the better. Also, just adhering to the principle of least privilege. That's sort of been a big problem with a lot of these things we've seen, are just too much access, and not restricting that. And then finally, like OWASP has a ton of resources. One, on what these vulnerabilities are, but two, how to test them, and three, how to fix them. There's just so much great stuff out on OWASP's website that really merits visiting, and just really good stuff. So with that, I'll be around if people want to ask questions, or just kind of banter about or whatever. I'm not sure how much time we have left in the official meeting. Hopefully I didn't run us over here or anything.
No, not at all.
Looks like we're right on time, actually. So, all right, with that, definitely thank you everybody for attending. And again, you can follow me on Twitter, hit me up on LinkedIn, or get a copy of the other version of the slide deck that's out there right now. Can do so.
Thanks, Matt. We appreciate you joining us and presenting this as a really great presentation.
Thank you.